We are going to perform tail test in Excel. We are going to use two variables like before cycle time and after cycle time. And aim of this video is that we are going to unfold these topics. T-test, we are going to do it in Excel and use the key fact, number one. Number two is that direct formula and through the formula syntax we are going to use. And t-test, again, during the direct formula, we are going to compare the result and how to interpret the t-test result. That is very important. That we are going to unfold. And lastly, change the number and to decrease the cycle time, but not significant. That also topic we are going to cover. So this is the data I have. I have taken the data which is random between the cells. What I can do is that I'll copy and paste it here. Let's do it one more time. Okay. So what I will do, I will take two variables and let's take random between the cycle time is between 10 minutes to 20 minutes. Okay. I just copy and paste it here. Now I got 25 value of cycle time between 10 to 20. Okay. I'll just paste this value. Maybe we can do it together later. So the same thing, what I will do, now I will just reduce it. So maybe I will say 8 to 10, maximum 10. Maybe there is an incident being there. And now the maximum cycle time is just 10. Okay. Now we have got. So now what I'm going to do is that I'm going to copy this value so that dynamically it will not change every time. We're going to keep this as a value. Now all these are values. So now we have two data sets. One is before cycle time and after cycle time. The first thing what we can do is that we can find out from the data analysis, and we're going to do C-test phase for two samples per minute. Right? The same process, so we're going to take phase station. Okay. And I'm going to keep the variables here. Let's say this is my one variable. Or you can directly keep this second. Since the label is there, so you can directly keep this column A and we're going to give column B. After cycle time, label and hypothesis mean difference. Let's say we can just assume it as one or two or 10, whatever the name. Now I'm not going to output I'm going to keep it right here. So now the analysis impact has given the value of phase feature, right? And with the phase feature, we got the cycle time. So a lot of features are there. What I will do, I will keep it. I'll keep it very easy. Now let's see. First thing we can see, we'll go one by one. First, we can see that mean from here, and maybe I will take another two columns. I say comparison, and I will take another one, which is comparison in percentage. For few things, we can take it percentage. We'll see overall comparison also. First, we can see from the mean cycle time from here. It used to be 15 minutes. Now it became 8.9. That means 6.6, right? What is the keep it in center? Okay. And now I will do the comparison. So how much cycle time is 1 minus this actual value divided by previous value. So 40% cycle time. Okay. Variance, again, I will copy this value, put it up here. That means variance almost 9 minutes reduced. In terms of percentage, let's see, 91% variation reduced. That's great. What we also need is that variance, I mean standard deviation. Now what I will do, I will add standard deviation, right? There are two ways we can do. One, let's check that value. For example, I will keep it here. I will keep it here. Standard deviation, sample, and let me see if the same value will So we got the standard deviation as 3. Let's see, we can also do another way. Square root of variance is standard deviation. We got the same value. So directly what I will do, I can do directly square root. That will be more better, right? Square root of variance is standard deviation. Okay. From the standard deviation standpoint, we have two standard deviations reduced. That in percentage, this is 70% standard deviations reduced. That's great. We'll take another sample, another one called standard error of mean. For that, what we need is that we also need n value, right? And maybe I can just put this. Okay, here observation, we already have an observation. Yeah, observation will consider as n value. Yeah. So here what we can do, the formula is standard deviation divided by square root of n. N is sample here. So 0.62 standard error of mean, 0.18. How much difference between these two? 0.43. How much in percentage? It is 70% because both are same, right? This is the square and this is variance, right? So almost 70% we have got it. Great. So now this is only one time we need. Here correlation between these two variables is 0.18. This we don't need. Since we have not given any value, hypothesized value, we have given 0. And we can also assume that, okay, maybe hypothesis value is 5 minutes we can give or anything. Degree of freedom for any variables, if you take it, for example, n. So here n 25. So degree of freedom is always equal to this value, that n minus 1. You will have the same value here, right? We don't need a decimal here for this. Okay. And then t-stat. T-stat we are going to do, right? And then t-stat is tail. How much tail is there? That's not very important value. What is very important value is this one. This shows that it is significant, right? We are also going to do in direct formula also as well, right? What the formula mean, how we can do, if it is, this is greater than 0.05, that is 5%, we will say not significant. Otherwise, call that as significant. Improvement in cycle time. Whatever the wording you want. So here, think is uh, very less than 0.05. So it says significant. So what I will do, I will just keep this here. I'll have the same form here. And this is a grade achievement. So what we can do, we can put this in the grade. The same thing we can apply here also. Right? So no, this is critical value, right? I mean, t-test 1, I'm sorry. So here, okay, it shows not significant. So why? Because it has taken this value. So here what is the reference? E22 we have, right? E22. Okay, so let's do it. This is one. This is we have done. So direct using analysis tool pack we have done, and we also compare these things also, comparison also done. And now what we are going to do is that we are going to do direct method. What is mean by that? For example, you can give t-test, right? And array 1, this is your array 1, comma, array 2, this is array 2. Okay. And now we are talking about two-tailed distribution because we need, because the value can go low or high. So it's a two-tailed distribution. And comma, type is going to be paired test, right? Okay. So we got scientific value. We can convert into this one. Exactly the same value we got. Similarly, you can go for, this is one tail, right? So if you see here, this is one tail. Sorry, I can put it like one tail. Even if it is one tail, the same value. Even if it is two tail, I'm gonna change into two tail. Is going to be same value. We got the same value. That means what the conclusion is, that interpretation is that yes, there is a decrease in cycle time. then we can consider this the revised cycle time as 8.92. This is one way. And the last way, what we also learn this interpretation, and we also learn this. Now what we are also going to do is that we are going to learn how to do through syntax, that we are going to learn now. So almost all the things we have learned. One last thing what we are going to do is that through syntax we are going to do. Maybe I'll keep it here through syntax. What we can do, we can go to formulas, and more formulas, statistical, and you come down and you'll find T, right? In T, these are all like this. You require array data you need, because we don't, I mean, the resultant value we need, and we don't have resultant value because we have in the array form, right? So what we can do, you can use this one. So you remember that this and this, what is the difference? So here it requires a resultant value, right? This also resultant value, right? And right tail or two tail, it requires a resultant value. This also it will return the left tail and all that. But what we have situation is that we have array, we have set of data. Just click here. And now here what we are going to do is that we are going to take before cycle time and after cycle time, and tail. So we can have one tail first, we'll do two tail, and then what is the number? So again we can put like two tails. So yeah, so you can see here almost a similar value you will get it. If you convert into scientific to general, you get the same value. Similarly, you can do the same thing also, right? Now, this is one scenario where the values are there and it is significantly changed. What I'm doing it, I'm just keeping this one more slide, right? And tab one more tab. Now, what I will do, I will just change everything, right? So let's do quickly and we can compare what is mean by significant, the last portion, right? What I'm going to do, I'll keep that before cycle time as it is, okay? And then what I'm going to do, maybe I'll keep it here same. Okay, what I'm going to do is that I'm going to keep, let's say this is between 10 to 20. Let's say this is random between 10 to 18. I'm not making much significant change, right? But I'm just making very small change here. Here is change, and similarly, we can get to know that the the data is not so significant. Why I'm keeping these two? Because I wanted to have introduced two more cells like standard deviation and other things. That's the reason. Standard error of mean. So that's the value. I will keep it as the value. So now let's do it. So how we can do? Quickly we can do. We can go to data analysis and t-test, and we are going to take this as the column A and column B. We'll, since we have already labeled, and we are going to keep the result here exactly in the same cell. Yeah, okay. So we got this value, right? So this value we got it, excellent. And now we can just keep it a little bit formatting, okay? And I'll keep it in center. And just like the before time, what we will do, we'll add these things, copy and paste it here, right? So you can see here, now it is the value we can see here, the significant value, that is very important. You can also, I'm going to keep the formula also as well. One tail, right? One tail. Okay, since it is still it is 1%, still it is 1%. So therefore, it is telling that it is significant. So what I'm going to do, if we have value which is not, since it is 5.33, still it is, I mean, 1, it is 14%, still it is significant. Like, let's assume that we have not made it this one. Maybe I can just change, or we can, if you wanted to modify this value, very narrower or identical like before and after, it will show there is a decrease, but it's not significant. In this case, both are very, very significant. I hope you find it useful. Please do like, share, subscribe, and channel. You have wonderful day.